So good evening all of you, welcome back to this sessions of engineering mathematics, and as in the continuation of this 7 p.m. series, in today's class we are going to look at single variable calculus lecture number 4 in this 2.0. okay, I hope I'm audible. And in this particular lecture we are going to focus majoritarily on the properties of definite integrals and as well as the applications of definite integrals, and of course in a single variable calculus, of course. Okay, so these are the things which we are going to focus, and basically these are the two Telegram channel links where you can get all the information. So here basically the Get Wallah English channel link, so any update on this channel will be followed basically on this Telegram channel. So this is the link to join, and this is my personal Telegram channel with PW, so you can actually access these two with these two QR codes. Okay, so if you have any issues you can just talk to us about if you want to talk to me in person, then you can follow this, and if you want to just get updated with all the technical things that's happening, you can just go on to this. Okay, and I request you to please install this U-Infinity. The reason being, you can have a track record of all your doubts at a particular place. Okay, and let's see, if you type, before asking your doubt, if you type exclamation doubt and then if you type your comment, it gets stored in the Unity at a particular location. Okay, so this is like a one-stop solution for all your queries and all your important points that you want to make a note of, course. Okay, so if you use this, you'll get much benefited. So let's quickly wind up with the last class lecture. So basically in the last lecture that I have taken, we were looking on integration. Okay, so we started with integration and we started looking at three theorems basically. One is fundamental theorem of integration, fundamental theorem of integration, and secondly we bothered about the mean value theorem of integration, where we have seen again some nice insights. Mean value theorem of integration, mean value theorem of integration, and the third thing being Newton-Leibniz rule is also what something we have worked out. Okay, so Newton-Leibniz rule. So basically when you have integration or basically differentiation of an integral symbol, then yeah, I'm fine now, thank you for asking. So Newton-Leibniz rule, of course. Okay, so these are the things that we have covered basically in the last lectures, and in today's lecture the prime focus would be on properties of definite integrals. So we have seen, we have given you some standard integrals and all. So in today's class we'll look at properties of definite integrals, which are again a bit important, and then we'll also look at some standard definite integrals like we have seen. Applications of definite integrals is also of course the first part is what we are going to see in this particular class actually. Okay, so before starting this properties of definite integrals, I've given you one homework question. Did anyone of you attempt to do that? So the homework question what I have given you is basically this question, right? So this is the homework question I have given you. So if some of you have solved, so please enter the answer. I'm giving only 30 seconds because if you have already solved, it's enough for you to enter the answer. Come on, enter this answer. All of you might have solved this question, so you had got one day in between as well. Come on, enter the answer of this question. The value of the definite integral, integral 1 to e root x ln x dx. Okay, hi. So let's solve this question. So I hope some of you have entered the answer. So let's see. Let I is equal to integral 1 to e root x times ln x dx. Okay, so as I told you in the highlight principle, so if you integrate, then first of all let's check the order. This is an algebraic function x power 1 by 2, and this is a logarithmic function which is ln x, of course. Okay, so you can swap these two. So this implies I is equal to integral 1 to e ln x times root x dx. Okay, so let's apply by parts. So if you apply by parts, first function into integration of the second. So what is the integration of root x? 2 by 3 x power 3 by 2. Okay, so that's the integration of root x function, minus integral derivative of this log x, which is 1 by x, into integration of this function is same again, 2/3 x power 3 by 2 dx is what you would get. Okay, and this limits are from this complete function. Just a second, so let me delete this minus here, and this complete function has limits from x is equal to 1 to x is equal to e, minus this function where the limits are from 1 to to e again here for this case, okay, because this is the simplified function. So x equal to 1 to x equal to e are the limits which you can apply, minus integral 1 to e 1 by x 2/3 x power 3 by 2. So clearly this x could cancel up this x power 1 by 2 times again, and this gives you I is equal to 2/3 x power 3 by 2 ln x within the limits x is equal to 1 to x is equal to e, minus, now what is integration of 2/3 if you take common, then integration of x power 1 by 2 is again basically 2/3 x power 3 by 2. So 2/3 x power 3 by 2 within the limits 1 to e, x is equal to 1 to x is equal to e, of course, okay. So it is just by parts which you can solve easily. So if you simplify, let's see what you will get. I is equal to, so if you replace e, it's like 2/3 e power 3 by 2, 2/3 e power 3 by 2 ln e is 1, minus, when you put x equal to 1, this ln 1 will give you 0. So this is the first term, okay. Then minus 4 by 9 times of 4 by 9 times of, if you simplify this, this is e power 3 by 2 again. So e power 3 by 2 minus 1, of course, okay. So this is the value. So if you simplify, this minus of minus gives you plus 4 by 9. So therefore I value is equal to, so you can check up, this is 2/3 and this is minus 4 by 9. So 2 by 3 minus 4 by 9, 2/3 minus 4 by 9 times of e power 3 by 2 minus, and this is minus of minus, so which is plus 4 by 9, of course, okay. So if you simplify this, how the options are formulated, so something like 2/3 minus 4 by 9. So if you multiply with the 3 and 3 here, it is 6 minus 4 2 by 9 times e power 3 by 2. So this e power 3 by 2 can be written as square root of e cube plus 4 by 9, of course, here, okay. So that's the value of I. Therefore integral 1 to e root x times ln x dx is equal to 2 by 9 times of root e cube plus 4 by 9, of course, in this case, okay. So that's the correct answer, of course, and this is the integration. So this was given in option 2 by 9 root e cube plus 4 by 9. So it should be plus 4 by 9. Option C is the actual correct answer, okay. So C is the correct answer. It's a simple integration by parts, but of course when people integrate this root x and ln x combinations, they feel slight mistakes in one of these steps. So that's why this question was given, okay. So C is the actual correct answer. So let's see. Okay, I think by the time you have entered, poll got finished. Sagnika, C is correct, yeah. Then let's see. Let us calculate certain, let us look at some properties, of course. So this is one question which I give you time again. So f of x is equal to r sin pi x by 2 plus s, and f dash of 1 by 2 is equal to root 2, and integral 0 to 1 f of x dx is equal to 2r by pi. Then the constants r and s are respectively. Come on, enter this. Single choice. I'm giving you some 150 seconds to solve this. Go. F of x is this function r times sin pi x by 2 plus capital X, where capital R and capital S are constants, okay. And f dash of 1 by 2 is equal to root 2. Integral 0 to 1 f of x dx is 2r by pi. So you have to calculate this. Come on, do it. Calculate the values of r and s. Normally these things can be done without using any properties in general. So please do this. Come on. So solve this question. You have two unknowns, capital R and capital S, and also you have two equations. This is one equation and this is another equation. You can solve. Come on, do this. C maybe. Okay, majority of you are entering C. Let's see what happens. It's like simple question, two equations with two unknowns. That's it. Okay. D. Okay. 4 by pi and 16 by pi is what Shravan is getting. Come on, quick. D. Vishwaranjan Mishra, you are also getting D. Okay. You told C previously. Okay. All the C's are getting D's now. Good. So anyway, let's solve this question. Meanwhile, the poll will end. So given f of x is equal to, so what is the value of f of x? R sin pi x by 2, r times sin pi x by 2 plus r sin pi x by 2 plus capital S. Okay. So this is capital S. So what is f dash of x, of course? So this implies f dash of x is equal to, capital R is constant, derivative of sin is cos pi x by 2 into the inner derivative of this, which is pi by 2. Okay. So this is pi by 2 plus S is a constant, so derivative is 0. Now the first equation that's given f dash of 1 by 2 is equal to, so what is f dash of 1 by 2 value, which is root 2. So this implies, so if you place root 2 here and x equal to 1 by 2 in this equation, this implies square root of 2 is equal to capital R cos pi by 2 into x by 2, which is pi by 2 into x is 1 by 2 of course, times pi by 2 in this case. Okay. So if you simplify this, this is cos pi by 4, so cos pi by 4 and this root 2 gets cancelled, so R is equal to 2 by pi in this case. Okay. So capital R value is square root of 2 by pi. That's good. So let's see, in all these options, in option A and also in option B, this C and D both have this value to be 4 by pi. Okay. So R value is 4 by pi. So C and D should not be the correct answers actually, right? Yes. Then how you have entered, or did I commit any mistake? So f dash of x is equal to R cos pi x by 2 into pi by 2 of course. So if you replace 1 by 2, the value is square root of 2. So root 2 is equal to R cos pi by 4 into pi by 2 of course. So if you cancel this, R is coming out to be 2 by pi. Yeah. Then how many of you have entered C and D? All of you? How come? Is this the case? R is equal to 2 by pi. Okay. So the answer is definitely in these two, A and B. But many of you have entered C and D. What happened? Did I do any mistake? No, right? Yeah, okay. R is equal to 2 by pi. Fine. Is this okay to all of you or not? Differentiation, right? Differentiation of sin is cos is actually minus sin is actually cos. Yeah, this is the sin function. So the derivative is cos. I think it's 2. Okay. Then let's go with the second function. Therefore, f of x is equal to r sin pi x by 2. So which is 2 by pi times sin pi x by 2 plus s of course. Okay. Now what is the second equation? Integral 0 to 1 f of x dx is 2r by pi. So given integral 0 to 1 f of x dx is equal to 2r by pi of course. Okay. So this is 2r by pi. Cos 45 is 1 by root 2. Yeah, correct. Thanks. This is the thing that overlooks happens. So let's see. This is cos pi by 2 into 1 by 2 into pi by 2 of course. Yeah, 2. Thank you. So cos 45 is 1 by root 2 of course. Sorry. Then in such case, this value is, so this is 1 by root 2. This is the reason why you should not do direct calculations. Okay. So this is 1 by root 2. So R is equal to 4 by pi of course. Okay. So R is equal to 4 by pi. Yeah, good. So R is 4 by pi then, because 2, 2 and pi. So then this term becomes, it's not 2, it is 4 actually here. So this is 4 by pi. Okay. Yeah, cos 45 is 1 by root 2. Thank you. These kind of things we do mistakes obviously. Good. So 0 to 1 f of x dx is 2r by pi. So if you integrate this, integral 0 to 1 4 by pi sin pi x by 2 plus s dx. Okay. So this value is 2r by pi of course. So if you simplify this, 4 by pi, what is the integration of sin minus cos pi x by 2 divided by pi by 2 of course. Okay. So this is pi by 2. Correct. 4 by pi times of minus cos pi x by 2, integration of this sin is minus cos actually. because differentiation of cos is minus sign. So minus cos pi x by 2 divided by pi by 2, of course. Okay, plus integration of this value is s into x. So within the limits s into x, within the limits 0 to 1 is equal to 2r by pi, of course. Okay, so you can simplify this. 2 can cancel this twice and this pi can be wiped off on both sides. Then this value is 2 into, so this is minus 2 by pi times of minus, because this minus is as usual, and this pi by 2, if you write it in the proper form, it's like 2 by 5. Then when you put x equal to 1, it's like, if you put 1 here, it's like cos pi by 2, 0 minus, when you put x equal to 0, it's like cos 0, so this is 1 plus s into 1 minus 0 is 1 is equal to r, of course. Okay, and what's the value of r? Capital R is 4 by pi, which we have solved, of course, here. Okay, so this is 4 by pi. So let's see what are the values here, of course, in this case. So it's like, this is okay, 2 we can cancel maybe. So if you cancel a 2, then it's like 2 by pi plus s is equal to 2 by pi, of course. Okay, and if these two steps cancel up, s is equal to 0 in this case. Okay, so the value of the constant is 0. Okay, so s is equal to 0. So r is 4 by pi and s is equal to 0, which is in option C, of course. So C is the correct answer in this case. Yeah. Okay. So this is correct, because cos 45 is not root 2, it's 1 by root 2. Sin and cos cannot go beyond 1. It's an overlook. Okay. So these kind of mistakes you should avoid. Okay, basically, and it's a simple integration. Then s is equal to 0. Okay. So these are the two examples which I thought of giving in this. So C is the actual answer. So C. Okay, Ashwini, Vishwanjan, Sujay, Pranav, good. Okay. Yeah, C is the correct answer, of course. Okay, because of this integrations. Then let's see. Let's look at some properties which could help you up. Okay. So before that, I want to give you one more question again. So solve this with the knowledge what I have given you. You can solve this. The answer would be an integer. So let's say again, I'm giving 120 seconds. Think and solve. Solve this question. Let f of x be continuous function on the real lines such that for any x this equation holds good. Then what is f of 2? The value of the function at x equal to 2. Hey Ashwini, let's solve karo na. Just solve the questions first. Okay, y to write 1, 2, 3 random numbers. Solve. Solve. It takes a couple of minutes to solve. Okay, quick. .12 maybe. So anyway, so let the poll finish. Let's write. So given f of x is continuous on complete real line and integral 0 to x square f of t dt is equal to x square times of 1 plus x square, of course. Okay, and you want the value of f of 2. Okay, we want the value of f of 2 obviously. So let's see. To calculate f of 2, we need not know what is the actual function. Okay, so what we can do is, look, integral taking derivative on both sides with respect to x, taking differentiation on both sides with respect to x. It's a single variable function anyway, on both sides with respect to x. Okay, so if you do this, then what happens? Look, d by dx of integral 0 to x square f of t dt is equal to d by dx of x square times 1 plus x square. Okay, so this is what you get. So ultimately, if you expand this, then what happens? See here, d by dx of integral 0 to x square f of x dx f of t dt. So basically, if you apply the Newton-Leibniz rule, it's like differentiation of an integral sign. So f of this upper limit, it's a composite function f of x square into derivative of this x square, which is 2x, minus f of 0 into derivative of 0 with respect to x. So this is how you expand the Newton-Leibniz rule, of course. Okay, so if you just differentiate, and it's product of two functions. So first function into derivative of second, because differentiation of 1 plus x square is 2x, plus second function into derivative of this first function is 2x, of course. Okay, so this is 2x. If you take common, it's like 1 plus 2x square is what you get. Okay, because here there is 2x and here also there is 2x. So if you take this 2x common, 1 plus x square plus this x square, so which is 1 plus 2x square. Okay, so this ultimately implies that 2x times f of x square is equal to 2x times 1 plus 2x square. Okay, so this is what you get. So this is Newton-Leibniz rule, no? Which I have taught basically in the first lecture of integration. Means basically in the last lecture I have given you this differentiation of an integration. We have even solved one question based on L'Hospital rule. You remember this? Newton-Leibniz rule. Basically in the last lecture I have taught about this. We have solved even one question based on limit x tends to 0 integral something. Okay, we have solved a question based on a differentiation of an integral even in last lecture. Can you recollect this? Yes or no? So if you do this, now if you replace x is equal to 2 on both sides, okay, so put x square is equal to 2, or else basically this, since this is valid at any point, you can cancel this 2x, let's say. Okay, and let's see, f of x square is equal to 1 plus 2x square. Okay, so we don't know what is f of x, but anyway we know f of x square is equal to 1 plus 2x square. So put x square is equal to 2 on both sides, because we want f of 2 value, correct? You want f of 2 value, so put x square is equal to 2 on both sides. So this implies f of 2 is equal to 1 plus 2 times of 2, which is 5. That's all. Okay, so 5 is the actual answer in this case. So therefore f of 2 is equal to 5 is what you get. Okay, clear? 7. Basically I have given you something like the Newton-Leibniz rule. If you remember, d by dx, or maybe I'll open the notes and will show you, which you can get easily, I guess. So downloads, and so the class I have taken is, of course, Survival Calculus 3. Yeah. So if you see, I have taught you something called the Newton-Leibniz rule, of course. Okay, one lecture before maybe. Yeah, in this lecture I think I have taught you. There is something called the Newton-Leibniz rule. After then I think definitely it should be here. This is mean value theorem of integration, and yeah, here it is. You can see Newton-Leibniz rule I have taught, and differentiation of a function when the limits are integral limits. You got this. Okay, so that's why f of this composite function. So here in this example you have x square. Here in this example you have x square. So f of x square into differentiation of this function, which is 2x, of course. Okay, so this side dash of x is basically 2x, and here this quantity is 0. So that's why this term completely is 0. You have only 2x into f of x square is equal to this. Okay, is this fine to all of you? Can you all recollect this? Yes or no? So that's why this is one question again based on that example, and this f of 2 value is 5. Okay, so 5 is the actual answer. If some of you have entered, let's see. Oh, none of you. Okay, maybe the thought of differentiating this equation was not in the mind. Okay, good. So let's see. Okay, fine. So let's start some properties of definite integrals, and then let's. Okay, so properties of definite integrals. So let's see if, for the first property, if f of x is not differentiable, if f of x is not differentiable at x is equal to c, where c belongs to a comma b, then ultimately at that point, since it's not differentiable, you have to split the integration. Integral a to b f of x dx, this value is equal to integral a to c f of x dx plus integral c to b f of x dx. Okay, so basically you can split this integration at that point x is equal to c, where the function is non-differentiable, of course. Okay, so second very important property, in fact this greatly many times helps in resolving the integrals. Integral a to b f of x dx. So if you have this function, this is same as integral a to b f of, instead of this x, if you can write a plus b minus x dx. Okay, so in the complete integrand, wherever you have x, you can always replace with a plus b minus x, of course. Okay, provided all these are constant limits. So you can actually show this, okay, by taking a plus b minus x is equal to t, you can see the conversions. Okay, so like for example, you can show by taking f of a plus b minus x is equal to t. If you want to show, okay, I'll show you maybe. So see here, consider I is equal to integral a to b f of a plus b minus x dx. Okay, so let's change a variable maybe. So let a plus b minus x is equal to t, of course. Okay, so a plus b minus x is equal to t. So this implies if you differentiate both sides, minus dx is equal to dt. So wherever there is dx, you can replace with minus dt. Now in definite integrations, whenever you are making substitution, you should also change this limits accordingly. Okay, so many times people forget to do this and they end up with wrong answers. So in definite integrals, when you are changing the function, if you are putting any substitution, ultimately you have to change the limits as well. So in this case, lower limit. So what is the value of lower limit? You know, a plus b minus x is equal to t. So this implies, so the lower limit of x, so when the integration is in terms of x, the lower limit is a. So a plus b minus a is equal to t. So t is equal to b. So this is the new lower limit in case of t integration. Okay, and what about upper limit? Again, a plus b minus x is actually your t, and in case of this x, the upper limit value is b. So a plus b minus b is equal to t, of course. And if you solve this, b and b gets cancelled, then in such case you have t is equal to a. So these are the four things which you have to substitute back in this integration. Okay, so therefore I is equal to integral, in this case the lower limit value is b and the upper limit value is a. F of a plus b minus x can be taken as t, and what about dx? Dx can be taken as minus dt. Okay, so this is minus dt. Now you know that using this minus sign I can swap these limits, correct? Because when we have defined the integration, we have seen the fundamental theorem gives you f of x dx. If you know the antiderivative, it gives you f of b minus f of a, of course. Okay, now if you swap these two limits, then ultimately there is a minus sign, because it becomes f of a minus f of b, which is a minus sign of this actual value. So therefore using this minus sign, you can swap these limits a to b and you can write f of t dt. So t is just a variable of integration, and this integration value or this integration value both will be same actually, yes or no? So therefore whenever you have this integral a to b f of x dx, this can always be written as a to b f of a plus b minus x dx, which is a very powerful conversion actually. Okay, so even in few cases you will find examples where, like, let's see. Okay, fine, so let's see this. Okay, so 2 is integral a to b f of x dx is equal to a to b f of a plus b minus x dx. Then the third thing which you can see is integral 0 to 2a f of x dx. This is equal to 2 times integral 0 to a f of x dx when f of 2a minus x is actually equal to f of x. Okay, so this is the case what you can write actually. So basically this integration can be written as this 2 which is in the top can be brought here if this function is symmetric about x equal to a, and 2 into integral 0 to f of x dx when f of 2a minus x is equal to f of x. Like in case of sin x, let's say if you have pi here. Okay, so if you have pi here, it can be written as 2 times of 0 to pi by 2 sin x dx, because sin of pi minus x is same as sin x. Okay, so in such cases this is helpful. Then fourth property, again one of the most drastic simplification property. If you have integral minus a to a f of x dx, then this value is equal to 2 times integral 0 to a f of x dx if f of x is even function. F of x is even function. And what do you mean by even function? Definitely this f of minus x, that is f of minus x is equal to f of x actually here. Okay, so this is even function, like you take the cos function, okay, or any function like x square, x power 4, x power 6 of that sequence, you can have this as f of x as even function. Okay, then 0 if f of x is odd function, is odd function of course. Okay, so this is odd function, that is f of minus x is equal to minus f of x again here. Okay, so that's basically the two steps which are very important again. So this is what you have. Then one again nice property which is basically the reduction property. In fact, I can show you this when I teach maybe something called improper integrals, which you will see again. So integral 0 to pi by 2, integral 0 to pi by 2 cos power nx dx is of course same as integral 0 to pi by 2 sine power nx dx. Okay, so which you can understand basically from this second property. Like you can see, if I take I is equal to integral 0 to pi by 2 cos power nx dx, then I can write it as integral 0 to pi by 2 cos of 0 plus pi by 2 minus x whole power n dx. Okay, and ultimately this is sin x cos pi by 2 minus x. So you have integral 0 to pi by 2 sine power nx dx. Okay, so that's what you would get. So ultimately these two are equal, and the value of these two, normally if you apply the reduction formula, you can see this value is something like n minus 1 into n minus 2 into n minus 3 into n minus 4 into n minus 5 and so on. This sequence will go on until you reach, this sequence will go on until you get 2 by 3 or 1 by 2 depending on n is odd or even respectively. Okay, so this sequence will end either with, see, let's say for example if n is odd, okay, then it ends with 2 by 3 ultimately, because again if you write the next term it becomes 1 and 0 on the top, which you not right. Okay, so this is 2 by 3, or if n is even it ends with 1 by 2 into k. What is the value of k? Where k is equal to 1 if n is odd. So if n is odd number, k is equal to 1, and k is equal to pi by 2 if n is even in this case. Okay, so if n is even, then k is of course pi by 2 actually here. So let's see, I'd like to give an example to show you. Example, if you have integral 0 to pi by 2 sine power 4x dx, let's say. Okay, so normally the technique what you generally follow is, of course, you will write integral 0 to pi by 2. This sine power 4x can be written as sine square x dx. Okay, so sine square x into dx whole square. So this is sine square x into whole square dx of course. And you can write this sine square x as integral 0 to pi by 2 1 minus cos 2x by 2 whole square dx. Okay, so this is what you'll write normally if you want to solve this integration sine power 4x. Ultimately this is how you do. And if you simplify this, 1 by 4 times of integral 0 to pi by 2, so if you expand this, 1 plus cos square 2x minus 2 cos 2x dx. Okay, so this is what you would get actually. Okay, and if you simplify this result, 1 by 4 into integral 0 to pi by 2, let's simplify, 1 minus 2 cos 2x plus this cos square 2x, again you can write as 1 plus cos 4x by 2 dx. Okay, so this complete function dx. If you integrate now as usual, so let's see, 1 by 4 into, now this is 1 and this is 1 by 2, so total 3 by 2. So integration of 3 by 2 gives you 3x by 2 of course. Okay, so 1 plus 1 by 2 gives you 3 by 2, and integration of 3 by 2 gives you 3x by 2. Integration of minus 2 cos 2x, so minus 2 into integration of cos 2x is sin 2x divided by 2. Okay, then plus integration of this cos 4x is sin 4x divided by 4 is what you have. Okay, so integration of cos is basically sin. Okay, so a high. Okay, So check here, this is 3x by 2 minus 2 sine 2x by 2 because of this integration, plus this cos 4x integration will give you sine 4x by 4, of course. Okay, so beta function se nikal sakta hai. We'll go. Okay, what is beta function, what is gamma function, we'll look later. So first, actually this question can be solved using beta function, of course, but before that I can give you this reduction formula with which you can get the answer very simply. Okay, so let's see, this is what you get. Maybe beta and gamma functions I'll deal in tomorrow's class, okay, once this applications part is done. So now if you replace these values, x equal to 0 to x is equal to pi by 2 for the whole combination, okay, for this whole terms, let's see what you get. 1 by 4 times of 3 by 2 into, now when you replace upper limit pi by 2 minus 0, so this is pi by 2 minus 2 gets cancelled, so sine 2x. So if you put x equal to pi by 2, it is like 2 gets cancelled and sine pi 0 minus when you put x equal to 0, this is again 0. Similarly, this term is also 0, of course. Okay, so the total value what you get is 3 pi by 8, of course. Okay, 4, 2 2s are 4 again, so 3 pi by 8 is what you get, obviously. So the answer is 3 pi by 8 in general. But if you apply this, so this is the classical way of doing this question. But if you do this, if you know this reduction formula, let's see what you get. So this can be written as, I'll write like, because one line is sufficient to write the answer actually, or so this is the complete solution with which you get 3 pi by 8, or integral 0 to pi by 2. So sine power 4x dx is what I have given you. Okay, so if this is sine power 4x, so first write this line, then it is 4, so start with 4, then 3, then 2, then 1, that's it. Okay, because after this 0 and negative will go into, then what is this value? This value of n is even. So if n is even, this constant k value is pi by 2, of course. Okay, so into pi by 2, of course. Okay, so that's what you have, which is, sorry, this is also 16, because 4 into 2, 8, 8 2s are 16. Okay, so 3 pi by 16, that's what you get. So here also, if you simplify this result, the answer is 3 into pi by 4, 2 and this 2 here. So this is 3 pi by 16. You can see with help of reduction formula, you can write these integrals within a single line, which is 3 pi by 16 like this. Okay, no need to even go for beta function. Of course, beta function is the basic how you get this formula. How you get this formula is basically depending on beta function. We'll see what is beta function in tomorrow's class and properties of beta function. But in general, if you know this property, the answer is 3 pi by 16 in a single line, of course. Okay. Yeah, 3 pi by 16. Sorry, this is 16 because 4 into 4 is 16, of course. So 3 pi by 16 is what you get. Okay. Fine. Is this clear to all of you? Did you all understand how to apply the reduction formulas actually? Every one of you. Please type in the chat box. Last line repeat. Okay. So this is based on this reduction formula again. So when you have integral 0 to pi by 2 sine power nx or cos power nx dx, then you start with n. Then once you write n, put n minus 1 here, n minus 2, n minus 3, n minus 4, n minus 5, and this so on. This series will eventually lead to either 2 by 3 or 1 by 2, depending upon n is odd or even. Okay, into k. This k value is 1 if n is odd, and k is pi by 2 if n is even, of course. And then you can apply that. That's what I have applied. Okay, so since it started with 4, I started with 4, then 3, 2, 1, and so on. After this, it will not go to 0 again. Okay, because if you see, it goes with 0 and negative series should not be there. It should end with 1 ultimately or 2. So it is 1 by 2. That's what you have. Into pi by 2, because this n is even. So k value is pi by 2. So if you simplify, you get 3 pi by 16, which is the same answer which you get by doing all these things. Okay. Or I'll give you one more example. Some 2-3 examples. Let's work out to get clarity. Integral 0 to pi by 2 sine power 8x or 7x dx. Let's say I start with odd this time. 7x dx. Okay, so integral 0 to pi by 2 sine power 7x dx. If you try to solve this, so let's see 7. So since it is 7, start with 7, then 6, 5, 4, 3, 2. If I write 1 here, I should write 0 here. Okay, so that's I'm not doing. So let's stop the sequence with this. Now what is the value of k actually? Okay, so let's see into k value. Now tell me this n is odd. So what is the value of k? 1 or pi by 2? Please tell me. Here this 7 is odd. So what is this value? K equal to 1 or pi by 2? Every one of you. Please type in the chat box. What is the value of k? 1 or is it pi by 2? 1, right? So k value is 1. So if you simplify this result, then you would get something like this 3, cancel this couple of times. Okay. and 5 and 7 are prime numbers. So 2 4s are 8, 8 2s are 16 by 7 5s are 35. So 16 by 35 is the actual answer. And if you use a calculator to get these values, 16 by 35, sorry, 16 by 35. So 0.4571, 0.457 is the actual answer in this case. Shall we check whether this result is correct or not? Pragnan Payash, okay, fine, good. So let's see, this is 16 by 35. So let's check whether we get this value or not. Okay, so let's check this. So let's open a Wolfram Alpha calculators maybe. So definite integral calculator. So let's see. Yeah, basically I use this very frequently. So let's say you go for this function. Okay, so let's see if you modify this function a bit. Math root of 1 minus 0.2 x square. This is elliptical integral basically. So let's see if you modify this function, integral sine x, let's close this, power 7. Okay, so sine x power 7. Integration limits are from 0 to pi by 2. Okay, good. So let's calculate this. So if you calculate this, you can see it's a graph, and basically it's how the expansion and all takes place. But integral sine 0 to pi by 2, I hope you can see maybe. So integral 0 to pi by 2 sine power 7x dx is 16 by 35, which we actually got because of this reduction formula, very simply. Okay, so if you calculate one more for getting clarity, integral 0 to pi by 2 cos power say 13x dx, which see, or 12x, let's say maybe, or sine power 12x, anything is fine, sine power 12 or cos power 12, the value remains same. So sine power 12x dx. So we have seen basically this is the size of the solution when this value is 4. Okay, but now when this value is 12 actually, so how we can do, let's say 12, 11, 10, 9, 8, 7, 6, 5, 4, 3 and 2, and here 1, there is no issue, so we'll end with 1 by 2 into the value of k. Many times people forget this k value. If n is odd, then it's not a problem, but if n is even, then you have to multiply pi by 2. Okay, so this is even, so let's say it is pi by 2. So this would be the value of this integration. So let's simplify. If you simplify this integral, so what we can do maybe, yeah, so 3 is prime, 5 is prime, 7 is prime, 9. Okay, 9 we can do something. So 9, 3 table 3 times, 3 table twice, of course, 3 is prime, 11 is prime. Okay, so let's keep it as it is. So 11 into, yeah, I think, okay, 5 can be cancelled. Here it is 2, of course. Then 7 2s are 14, no, 11, nothing can be cancelled. 3, okay, nothing much left. Okay, so let's see, 11 into, this is 21, so 11 into 3 7s are 21 into 3, of course 9, so basically 9 7s are 63. Okay, so I can write 63. 11 into 3 7s are 21, 21 into 3 is 63, divided by 12 into 8, 96 into 2 2s are 4, 4 4s are 16, 16 into 4, 64 into pi, of course. Okay, so this is the value, and if you simplify this, let's see how much you get. 11 into 63, 11 into 63 into pi, of course. Okay, so first let's get only this constant. 11 into 63 by 96 into 64, 96 into 64, so 0.11279, 0.11279 times of pi. And if you multiply this value of pi also, let's check how do you multiply. Into pi symbol is here, so you can click pi. So this is 0.3543, 0.3543 actually. Okay, 0.3543, clear. So let's check whether 3 with 12, yeah, 3 with 12 can also be done, but anyway the final answer is that's the point of interest. We had a calculator, no issue. So let's calculate this sine power 12x. Let's go to this integrals again. So let's modify this function. Sine x power 12 is what I have taken. Okay, so sine x power 12 is the function actually. If you have taken sine power 12 or cos power 12, the answer would have been same, no issue, because of this understanding. So both these integrals are same. Okay, so let's calculate this integral, and let's see. Sine x power 12x dx 0 to pi by 2 is the integration. So let's calculate this. So you can see after simplification it's something like 0.35435, 0.3543, and I think in the calculator the next digit is 5, 0.3543. If you round off, it is 5 again. Okay, so that's the actual answer. Okay, good. So these are I generally when I do with elliptic integrals. We'll see what is an elliptic integral again in tomorrow's class maybe, but this is how we solve. Okay, did you all enjoy comparing the results? All these techniques are basically with the help of beta and gamma functions actually, to be fact. Okay, but how this is coming I'll show you in the upcoming class, maybe in the tomorrow's class. Okay, so let's see one more reduction formula I want to give you. If you have okay, maybe in the fine. Okay, so let's see here. I can give the value of, this is also helpful many times. Okay, so the value of integral 0 to pi by 2, say sine power mx into cos power nx dx. Okay, so this is what we have in general. Okay, so let's say sine cube, cos power 4, sine power 9, whatever you have. So this value is equal to, or this value is equal to, so it starts with m plus n into m plus n minus 2 into m plus n minus 4 into, means every alternative term, and so on. This series will eventually end with either 2 or 1, of course. Okay, and in the numerator we have m minus 1. It should start with m minus 1. Okay, so please be careful. M minus 1, m minus 3, and so on, again 2 or 1 depending upon its even or odd, into again n minus 1, n minus 3, and so on, 2 or 1 again depending upon even or odd. So this value multiplied with k. So what is the value of k again? So k is equal to pi by 2 if both m and n are even, because you will see in gamma function gamma of 1 by 2 is root pi, so that root pi into root pi will actually give you this pi, of course. Okay, so but anyway we'll see this. So pi by 2 if both m and n are even. Okay, and 0 otherwise. So basically if one of them is odd or if both are odd, in all these cases it is 0. Okay, it's pi by 2 only if both m and n are even in this case. Again, this property will also helps get in reducing the size of the integrals. Okay, so let's see example. I would like to work out an example. Integral 0 to pi by 2 sine square x cos square x. Let's take a simple example, even you will see the size we can have. Okay, so sine square x by cos square x. This integration will actually give you something like 0 to pi by 2 sine square x into cos square x dx. So we can write as integral 0 to pi by 2, or how I can do this? Yeah, okay, fine. 0 to pi by 2, maybe I can multiply a 4 and divide with 4 outside. So 4 sine square x cos square x dx. Okay, so that's what I can do. Maybe you can multiply a 4 and divide with 4, then ultimately 4 gets cancelled, you'll get the same thing. So this is something like 1 by 4 integral 0 to pi by 2, this is sine 2x whole square. Okay, dx. So this is sine square 2x, so ultimately sine 2x whole square can be written as sine square 2x. Okay, so sine square 2x is 2 sin x, cos x is this. Then 1 by 4 times of, now it's a known job, this sine square 2x can be written as 1 minus cos 4x by 2 dx, of course. Okay, so that's what you get ultimately. So 1 minus cos 4x, because 1 minus cos 4x is 2 sine square 2x, and 2 gets cancelled, so that's the term you have. So 2 I am pulling it out, so 1 by 8 times integration of 1 minus cos 4x, so x minus, so integration of cos 4x is sine 4x by 4, of course. Okay, so sine 4x by 4 within the limits 0 to pi by 2. So if you substitute these values, 1 by 8 times of, if you replace this pi by 2 minus 0 is pi by 2 minus 1 by 4 into, okay, oh, just a second, this 2 if you take out, okay, then, okay, this integration is 1 by 4 into, then if you replace pi by 2 here, it becomes sine 2 pi, so sine 2 pi is 0, and when you put 0, that's also 0. So basically the second term is 0, so this value is pi by 16. Okay, so pi by 16. So this integral value is actually pi by 16 is the actual answer. Integral 0 to pi by 2, and imagine the powers are very small, it's 2 and 2, that's it. Okay, so sine square x times cos square x dx is of course pi by 16, that's what you got. Okay, Now we'll do the, and of course this is the size of the solution when these two are very simple, 2 and 2. So let's imagine if you have 4, 6 things like that, it would have been very long calculation. Okay, so let's see an alternative technique to calculate this, or integral 0 to pi by 2 sin square x cos square x dx. Okay, maybe they can be different as well. I'll show one more example. So first of all, let's work out the simplifications. So m plus n. So now look at this formula, reduction formula. Here it is m and here it is n. So m plus n is the first term. So m plus n gives you 2 plus 2 is 4 into, then after alternative terms, it's not like m plus n minus 1, the next term is m plus 1 minus 2 actually. Okay, so if this is 4, then the next term is 2 and the next term would be 0. So we'll stop with here. Okay, then starting the numerator, first of all dealing with this m minus 1. So here m value is 2. So m minus 1 is 1 actually. That's it. That's the first and last term that we have in this expansion. Into, if you have this 2 here, then again the n minus 1 means this second part of the sequence will also be just a 1. That's it. Okay, and into, what is the value of k? Both are even. So k is pi by 2. So which is pi by 4 2s are 8, 8 2s are 16. That's it. Okay, so that's all you have. That's all you have to do. So the answer is actually pi by 16. And now let's work out some complicated example. Maybe integral 0 to pi by 2 sin power 5x into cos power 7x dx. So this would have been really a bit long calculation. If you attempt to do this question, then ultimately it's a long calculation. Okay, so in fact how you do this is, see, I'll tell you. Normally the classic way of doing this, when people give these things, let's say this reduction formula and all, if you forget, you can do it in one way. Integral 0 to pi by 2 sin power 5x into this cos power 7x can be written as cos power 6x into 1 cos x dx is what you can do actually. Okay, so this is integral 0 to pi by 2 sin power 5x. Now this term can be written as sin square x whole cube, so or cos square x whole cube, so that can be written as 1 minus sin square x whole cube into cos x dx. This is what the actual way of doing this question. Okay, and if you make now the substitution, let sin x is equal to t, let sin x is equal to t, this ultimately implies cos x dx is dt if you differentiate both sides. Okay, so what about limits? Lower limit is sin 0, because the lower limit of x is 0 is equal to t, so t is 0. What about the upper limit? Sin pi by 2 is equal to t, so this implies t is equal to 1. So basically if you call this I, let's say if this is I, the integral, then this I can be replaced with, if you substitute all these things, these 4 things in this integration, you have I is equal to integral 0 to 1, because lower limit is 0 in t, upper limit is 1 in terms of t, so 0 to 1. So sin power 5t, so t power 5 into 1 minus t square whole cube into cos x dx is dt, of course. So if you solve this, okay, so if you solve this equation, so integral 0 to 1 t power 5 times of, if you expand this, normally a minus b whole cube you can expand, so 1 minus a cube, so a cube minus 3a square b, 3a square b plus 3ab square minus b cube. Okay, so this is what you get, dt. So ultimately if you multiply this, you have integral 0 to 1 t power 5 minus 3 t power 7 plus 3 t power 9 minus t power 11 dt. Okay, so this is what you get, t power 11 dt. Now if you integrate, you can have t power 6 by 6 minus 3 by 8 t power 8 plus 3 by 10 t power 10 minus t power 12 by 12. So this limits of integration will go from t equal to 0 to t is equal to 1 actually. Now ultimately if you put t equal to 0, each and every term is 0, but if you put t equal to 1, it becomes 1 by 6 minus 3 by 8 plus 3 by 10 minus 1 by plus minus 1 by 12, of course. Okay, so this is the value if you put t equal to 1. Now what about the LCM? Actually this is 6, 8, 10 and 12, of course. Okay, so 120 is the LCM if you take, so multiply with if you want 120 here, just multiply 20, so 20 minus, if you want 120, multiply 15, so 45 plus 36 minus 10 by 120, of course. Okay, so this is the value which you get ultimately, because if you take the common LCM to be 120, then 20 by 20, so then this becomes 120. 8 into 15 120, 3 into 15 45, so that's 45. 10 into 10 into 12 actually is 120, so 3 into 12 is 36, minus 12 into 10, so 10 is what you have here. So if you simplify this result, let's say this is like 56, so 20 plus 36 is 56, 56 and 45 minus 10 is 55, so 1 divided by 120 is the actual answer, the final answer of this. Okay, so therefore integral 0 to pi by 2 sine power 5x into cos power 7x dx is of course equal to 1 by 120 actually. Okay, but you have done a lot of things to get this answer, but if you know the reduction formula, you can still get this answer within a single line. Let's see how you can get that. So, or the method you can have is integral 0 to pi by 2 sine power 5x into cos power 7x dx. Okay, so this is what you get. So let's see, let's write the summations. So first of all, m plus n, so 5 plus 7 is 12. Okay, so 5 plus 7 is 12. So if you start with 12, then write alternative terms 10, 8, 6, 4, 2. Next alternative would be 0, so we'll stop here. Okay, then m value is 5, so start with m minus 1, so 4, then after alternative 2, and after alternative term is 0, so we'll stop here, into n minus 1, so n is 7, so start with n minus 1, so 6, then 4, then 2, and we'll stop here because again the next alternative would be 0, so we'll stop this alternative terms. What is the value of k here? Look, I told you k value is pi by 2 if both are even. At least if one is odd or both are odd, k value is only 1. Okay, so it's not pi by 2, so it's only 1 actually. So if you simplify this result, let's see what you get. 4 2s are 8, 6 4 2 cancels the 6 4 2, so finally you have nothing in the numerator, so 1 divided by 12 times are 120. That's it. Okay, so that's how reduction formulas will greatly save time when you have to do calculations. Okay, and many times we'll take the advantage of this reduction formulas and we'll simplify a lot of things. Okay, fine. Did you all understand how to apply the reduction formulas and solve? Okay, and in case if you don't remember the reduction formula, you can apply this procedure, and in tomorrow's class I'll teach something called beta and gamma functions, where again you will see some technique to solve these integrals. Okay, but this is the shortest way in which you can get the integral value. All even or all even into odd. The k value is pi by 2 only when both are even. Okay, if either one of them is odd or if both are odd, the k value is only 1. Got it? Yeah, so please type in the chat box, is this okay to all of you? Is this clear to all of you or not? Did you all understand basically how to apply the reduction formula and simplify the things? Now one more property which I would like to give you is generally, so these are the basic important properties that you keep leveling up in general, this 5 6 7 properties whatever I have given you. Now the next property is, or it's a result basically rather than talking as a property, the value of integral a to b f of x divided by f of x plus f of a plus b minus x dx is actually b minus a by 2. B minus a by 2. So this is definitely a direct integral. I applied second for in exam. In university exams you don't apply this, okay, because if people don't know then they strike off. So this integral value is again b minus a by 2, which is again a very powerful result which we keep using many times. Let's see how we get this. Example, so let's solve this directly. So solution, how this is the way. So let I is equal to integral a to b f of x by f of x plus f of a plus b minus x dx, of course. Okay, so this is dx. So let's say this is equation, basically I have taken this as I. Okay, so let's call this equation 1. Now if this is the total integrand of this interval of this integration, wherever there is x, can I replace x with a plus b minus x because of this property, because of this result? Wherever you have x, can I replace with a plus b minus x in the complete integration? Correct? So this implies I is equal to integral a to b. So integral a to b, of course, in place of x, I am replacing a plus b minus x divided by f of, in place of x, a plus b minus x plus f of a plus b minus, in place of x, again you replace a plus b minus x, of course. Okay, so dx. Now if you simplify these results, let's see, this a and a, b and b gets cancelled. This minus of minus will give you plus x. So which means this integration is something like a to b, it's a single variable integration. So a to b, f of a plus b minus x divided by, now f of a plus b minus x plus f of, now these terms got cancelled, so minus of minus gives you a plus sign, so x dx. So this is what you get. Okay, so this is equation number 2, let's say. Okay, so maybe let's call this, so this implies I is equal to, so this is equation number 2 in this case. Okay, so this is equation 2. Now if you add these first and second equations, let's see what happens. Therefore 1 plus 2 implies, so what is LHS in this first equation? I is the LHS. In the second equation also I is the LHS. So I plus I is 2I is equal to, now when you add the right hand sides, if you look at this integration and this integration, the integrating variable is same, of course, x, and the limits of integration is also same. So the limits of integration is also same actually here. If one of the odd values, okay, so in reduction formula just before you wrote k equal to 0 for one odd values of k. Is it? Oh my god, that's the case, then it's like, guys, sorry, please correct this to be 1. Okay, this is 1. Thanks Sakshi. So this value is 1. Okay, please change it. Okay, yeah, please change this value. This is actually 1. Okay, I hope all of you might have changed. It's not 0, sorry, it is 1. Maybe now look, I have written it's 1. So let's see. So 2i is equal to, now coming back here, so this orange integral and this blue whatever I have written, these are the same integrating variables and the limits of integration is also same. If limits of integration is same, then can I put these two integrals under a single integral sign, which means can I write this as integral a to b. What is the first integrand? This is the first integrand, f of x by f of x plus f of a plus b minus x, of course. Okay, so this is the first integrand. Now when you write the second integrand, actually you're supposed to write plus f of a plus b minus x divided by the same integrand, because you know this denominator is same as this denominator, because addition can be, addition of two functions is commutative. So this addition or this addition is same, which means the second integration, instead of writing as a separate thing, I can write it as plus f of a plus b minus x dx. Will you all agree with me if I write this? Yes or no? Correct. So can I write this? Basically if I add these two, because the integration limits are same, so I can write both the integrands in the same integral, and if I write it in the same integral, the denominator is same, so I can just add up the numerators and I can bring this part. Is it clear to all of you? Yeah, so please type in the chat box, is this clear to each and every one of you? Yes. So then this value cancels out. Okay, so this is integral a to b 1 dx, which is b minus a. That's all. Okay, so therefore I is equal to b minus a by 2, and this implies, what is I? Integral a to b f of x by f of x plus f of a plus b minus x. If you have such integration, then the answer is definitely b minus a by 2. Okay, so sometimes what happens, this integral a starts with 0. Okay, so the lower limit value is 0. It's like integral 0 to b f of x by f of x plus f of b minus x. In such case, you know, if a is equal to 0, this implies integral 0 to a f of x by f of x plus f of a minus x dx is equal to just f of this value is equal to just b by 2 because this a is 0. So if you find any of this integral, the answer is just half of this upper limit value. That's it. Okay. So now in GATE exam, how questions came on this? Let's see. Examples. I'd like to mention few examples. First, integral 0 to pi by 2 sin x by sin x plus cos x dx. What's the answer? Normally, let's say you don't know this technique, and if I give you this integration, then it's like adjusting a plus cos x minus cos x, doing all these things is very complicated. Okay, so then can someone tell me what's the answer in this case now, since you know these techniques? Come on, a bit faster. What would be the value of that integral? What is the value of this integration? This limit is 0. Okay, pi by 4. That's it. What is this answer? What is the value of this? Integral 0 to a root x is the function. So root x by root x plus root of 0 plus a minus x, so which is root a minus x. What is the value? A by 2. Good, fantastic. At bottom b should be not a. Where? Here, because I have put a here, no? Okay, Mausam Mukhya. At bottom it's not b because it's a, because 0 plus a is a minus x. That's it. What is this value? Pi by 4 again. Okay, so this is pi by 4. The reason is this integration can be split up as 0 to pi by 2. If you expand this tan x as root sin x by root cos x dx, of course. So this value is integral 0 to pi by 2. This, if you take LCM, it's like root cos x by square root of cos x plus root sin x dx. That's it. Okay, so sometimes they give you the shorthand notations like this, where you should be good enough. The left part, yeah, thank you. Here it is. Thanks. Okay, because b is there obviously, so a is 0, b minus x. So this all things you have a bit to simplify. Okay, got all? Is each and everything clear about this particular simplification, or in general about this result? Okay, so this is again some nice result where all these are actually previous GATE questions kind of thing, where people use this property in order to. Okay, then let's see one more important integral. Actually, the value of integral 0 to pi dx by a square cos square x plus b square sin square x. If a equal to b, then the answer is very simple. If a is equal to b, the answer is pi by a square. That's it. Okay, because you take a square common, cos square x plus sin square x, it's 1. So integral 0 to a 1, 0 to pi, this is dx. Okay, so this is equal to pi divided by a b, of course, in general. Okay, so if a and b are not equal, it's pi by ab. If a and b are equal, then ultimately this becomes a square. So you can take this a square out, then pi by a square is the actual answer. Okay, so let's see how this integration can be shown. Again, this is also very important. Why? I'll tell you. So see here, let I is equal to integral 0 to pi dx by a square cos square x plus b square sin square x is what you have. Okay, so that's the term. So ultimately I have told you one property, like since integral 0 to 2a f of x dx can be written as twice integral 0 to a f of x dx if f of 2a minus x is equal to f of x. Okay, so I have taught you this basically in one of the properties I have shown you. So that actually obeys here. Okay, so this implies I is equal to 2 times integral 0 to pi by 2 dx by a square cos square x plus b square sin square x, of course. Okay, the reason for that being, if you take cos pi minus x, it is minus cos x. Okay, cos pi minus x is minus cos x, but there is a square on the top, so minus cos x whole square is again cos square x. So this function remains as it is even if you write pi minus x. Similarly with sin, there is no issue. Sin pi minus x is sin x by default. So if you take square, it directly gives you sin square sin square x. Okay, so what I can do is, maybe I'll take this cos square x common. Integral 0 to pi by 2. If I take this cos square x common, 1 by cos square x I can write as secant square x dx in the numerator by then what about this a square plus b square tan square x is what you will get. Yes or no? 2. Can I write this integration as this? Because if I take this cos square x common, 1 by cos square x will give me this secant square x on the top, and then this a square will be left as it is, plus 1 cos square x comes in the denominator, so sin square divided by cos square gives that tan square actually. 2. Can I write it this way? So please type in the chat box. Can I do it? Yes or no? Again, please type in the chat box. Is this understandable to all? Everyone, whoever is on live, please comment. Is this okay? Now at this point, let's make a substitution. Okay, so let's make some substitution. Let maybe b tan x is equal to t. Okay, so this implies b secant square x dx is equal to dt, of course. Okay, so b secant square x dx is equal to dt. If b secant square x dx is equal to dt, then what about the lower limit? B tan x equal to t, so b into tan 0 is equal to t. So what about t? T equal to tan 0 is 0, so the lower limit is 0. Upper limit. So what about the upper limit? B tan pi by 2 is equal to t. So this implies t tends to infinity. So this is the upper limit, of course. Okay, so the upper limit is 0. Secant square, how? Okay, I'll maybe elaborate here. If I take cos square x common here, okay, then this 1 by cos square is actually secant square, which I have written in the numerator, and this sin square by cos square is actually tan square. Okay, now it's fine. I think some of you had issue in understanding this conversion, but this is the way I have done. Okay, so this 1 by cos square x is now secant square x, and this sin square x by cos square x is actually tan square x. Okay, fine. Okay, yes or no? Please type in the chat box. Everyone, is this okay to all of you or not? So if this is okay, then let's substitute these 4 things in this integration. So therefore I is equal to 2 times of integral 0 to infinity, because the lower limit in this new case is 0, upper limit is infinity, secant square dx. So what is secant square x dx? dt divided by b. Okay, so this implies, maybe I'll write a word here, secant square x dx is equal to dt divided by b in this case. Okay, so if you write this numerator, it is dt by b by a square plus t square. That's it. Okay, so now you can pull out this b. So this implies I is equal to 2. This b can be brought to the denominator. Integral 0 to infinity 1 by a square or t square plus x a square, which you are familiar in this way. This. So what is the integral of this? I have given you basically 1 by x square plus a square in the last class into 1 by a times tan inverse t by a within the limits 0 to infinity. So this value tells you 2 by ab into, because a and b are constants, tan inverse of t by a. So if you put infinity here, so when you put infinity, tan inverse of infinity gives you pi by 2 minus tan inverse of 0 gives you 0, of course. Okay, so ultimately this 2 and this 2 gets cancelled, so pi by ab is the actual answer. So therefore integral 0 to pi dx by a square cos square x plus b square sin square x is equal to pi by a b is what you get. Okay, so this is pi by a b. Now the idea is why this result is important. That's the question. Why I have shown so much effort and shown this result actually. Again, there are many gate questions, and of course, not only in gate, in many competitive exams, the questions get basically using this integration. Okay, we'll see how it comes. Example. Let's say if I give you something like integral 0 to pi dx by 4 sin square x plus 9 cos square x, something like this, the answer is going to be pi by 6 because of this technique. Okay, because a square is 4, so a is 2, b square is 9, so b is 3, so a into b, 2 into 3 is 6. So if question come as it is in this way, it's very, you can see, okay, it's a direct thing, we can do this. Sometimes the questions comes up like this: 0 to pi dx by 4 plus 9 cos square x actually. Okay, so dx is on the top. So they'll ask you questions like this. Have you seen questions like this? Integral 0 to pi dx by 4 plus 9 or a plus b cos square x, a plus b sin square x. They might have given questions like this if you have seen. Okay, so in such case, what you can do is integral 0 to pi dx by, this can be written as 4 into 1. This 1 can be written as sin square x plus cos square x. This term becomes 4 sin square x plus 4 plus 9, 13 cos square x. So which means the integrals of this form can be converted to this, for which you know the answer directly. So this is pi by 2 times square root of 13. That's it. Okay, because this 13 can be written as root 13 whole square. So pi by 2 root 13 is the actual answer. Got it? Yes? So please type in the chat box. Is this clear to all of you? Yes or no? Yes. Something? Okay. Pi by 2 root 13 is the actual value of this particular integral. Okay, so many times questions develop like this, so in such case it's helpful. Can someone tell me, instead of 0, instead of pi, if you have 2 pi, okay, if you have 2 here, okay, 2 into pi, can someone tell me what is the value based on the properties? Again, if you think, if let's say instead of pi, if you have 2 pi, then what would have been the answer? If you have 2 pi here, it's 2, then what would have been the answer? So please tell me, type in the chat box. 2 pi by AB, that's it. Okay, because the reason is, yeah, it is 2 pi by AB, of course, because if there is 2, this integral could be written as 2 into integral 0 to pi. Okay, because cos 2 pi minus x is cos x, of course, sin 2 pi minus x is minus sin x, but because of squares, this function remains as it is. So if you have 2 pi, then 2 into something would come. Okay, 2 into same thing would have come. So these are basically the properties which could help you in definite integrals and some standard integrations which you can calculate. Then let's see in the applications. First, I would like to start with area between the curves. Okay. First application, the common application which many of you will get, area between the curves. Okay. So let's see in this case, if the functions f of x comma g of x are differentiable for all x belongs to a comma b, or open intervals you can say a comma b, and f of x is greater than or equal to g of x. F of x is greater than or equal to, or greater than g of x, let's say, because if it's equal, it's 0 by default. If f of x is greater than g of x for all x, then the area bounded by the curves y equal to f of x, comma y equal to g of x, comma x equal to a, comma x equal to b is given by a is equal to integral x is equal to a, okay, to x is equal to b, f of x minus g of x, which is again some function of x dx. Okay, so it's a single variable integration. So f of x minus g of x dx. So in general, if you have two curves like this, okay, just a second. Oh, something went wrong. Just a minute. So let's see. If you have curves like this, let's say origin x, y. If you have two curves something like this, okay, depending on the geometry and shape, you can have f of x and x is equal to a is something like this here, and x is equal to b is something like this here. Okay, so in such case, so if you shade up, this is the area. So that area is given by this integration in general. Okay, but for that to happen, this f of x should be always greater than g of x actually. Okay, otherwise, if at some point if they're crossing, then at that point of crossing, then g of x, if it comes on the top, then you have to split the integration at that point, obviously. Okay, so let's see. Let's solve one example maybe. So before we proceed further, because I've been teaching theory for so much time, calculate this integration. What is the answer of this integration? Integer type. So yeah, maybe 120 seconds I give. Yeah, good enough. Solve. So solve this integration. The value of this integral. Solve this integral. For now, Vijay is 0. Let's check. Okay, so let's see. Let's solve this integration. Maybe one of you are telling 0, one of you are telling it's 1. Okay, no 2. So let's check it. Solution. I is equal to integral 0 to 2 x minus 1 whole square times sine x minus 1 by x minus 1 whole square plus cos x minus 1 dx. Okay, so this is what we have. So let's apply this property, which is like, since integral a to b f of x dx is equal to integral a to b f of a plus b minus x dx, of course. So this implies I is equal to integral 0 to 2 a plus b minus x minus 1, of course. Okay, because this x can be replaced with a plus b minus x. This minus 1 is as usual. Sine a plus b minus x minus 1 divided by, so this value divided by, again here if you write a plus b minus x minus 1 whole square plus cos times a plus b minus x minus 1 dx. Okay, so this is what you get, of course. Then if you simplify this result, this value is integral 0 to 2. So you can see 0 plus 2 minus 1. So 2 minus 1 is plus 1. So 1 minus x whole square. Similarly, this value is also 2 minus 1 minus x. So sine 1 minus x by 1 minus x whole square plus cos of 1 minus x, of course. Okay, dx. This is what you get. Okay, that's the integration. Now this is sine of minus of x minus 1. This is also cos of minus of x minus 1. Okay, so this tells you I is equal to integral 0 to 2. Look carefully. This can be written as sine of 1 minus x can be written as, and this 1 minus x whole square can be written as x minus 1 whole square as usual, because it's a square. So even if you write 1 minus x whole square or x minus 1 whole square, it doesn't matter. Into sine of 1 minus x can be written as minus sine of x minus 1. Correct? I can write it divided by x minus 1 whole square plus, and this guy cos of 1 minus x or cos of x minus 1, it is same. So cos of x minus 1 dx, obviously. Okay, so plus cos of x minus 1 dx, because obviously if you replace this 1 minus, if you write it as minus of x minus 1, cos of minus theta will give you the same thing. Now if you take out this minus sign, okay, so if you take out this minus sign, this implies I is equal to minus. Now can someone tell me what is this integral? Integral 0 to 2 x minus 1 whole square sin x minus 1 by x minus 1 whole square plus cos x minus 1. Can someone tell me what is this integration value? By looking here, what is this value of integration? Can I write it as I? Yes or no? 2, because this integral is same as the given integration actually. So I is equal to minus I is what I get. Yeah, can I do this? Okay, fine. So please type in the chat box. Can I do? So which means this ultimately tells you I is equal to 0, of course. Okay, so that's what we have. I is equal to 0. So basically this integration is, it's not always possible to integrate this function and get the value. Okay, yeah, I can say it again. So okay, let's go step by step. Till here, is it clear? 7, is it clear till this point? Okay, so if this is clear, then what I have done is basically instead of this x, I can replace a plus b minus x. So that's why instead of this x, I have written 0 plus 2 minus x. Similarly here, instead of x, I have replaced 0 plus 2 minus x at all these places. So if you simplify, then 2 minus 1 is plus 1, so 1 minus x. So this complete bracket becomes 1 minus x, which is here. Similarly, each and every bracket becomes 1 minus x. Okay, so this is 1 minus x, 1 minus x, 1 minus x. But these two terms can be retained as x minus 1 whole squares. Okay, because 1 minus x whole square or x minus 1 whole square is same. So these two terms can be retained as x minus 1 whole square. Now coming to this term, sine 1 minus x can be written as sine of minus of x minus 1. I can do this. So which can be written as minus sine x minus 1. Okay, so that's why x minus 1. So that's why this sine 1 minus x is basically minus sine x minus 1, and this cos of 1 minus x can be written as cos x minus 1, because cos of minus theta or cos theta both are same. So this can be written cos x minus 1 obviously. Then if you delete this minus sign and write it outside, this integration which is on the right hand side is completely the same value I. So I equal to minus I, which can happen only when I is 0. So this integration value is 0. Okay, that's now one question I'll give you homework before we leave today. So let's see. So solve this question. It's a homework question for you, which we'll see the solution in tomorrow's class. I mean on Monday's class again. Okay, so please solve this question, and this is like a homework. We'll see this on Monday again, and okay, yeah, that's it. So this is the question which you can try up. So let's see. Yeah, if you have doubt, please ask me always. Okay, please don't hesitate to ask doubts. Ask as many doubts as you want. Okay, So meanwhile, I'll just write the summary. So we have seen some nice definite integrals in today's class, and some nice properties of definite integrals, especially the reduction formulas and all, which helped us. Properties of definite integrals. We have just started applications, but we will soon finish this. Okay, maybe in the Monday's class. Okay, so applications, like basically areas is what we have seen, but of course we'll solve some questions on areas and all. I'll give you one more question. Maybe if you see one more homework question, I'll give you. Homework again, problem number 2. Area bounded by the curves y equal to cos x, y equal to sin x between x is equal to 0 to x is equal to pi by 2 is dash. Okay, maybe you can round off to a couple of decimals. So round off to 3 decimals. Okay, so this is one more homework question. So solve this because you have holidays in between. So solve these 2 homework questions and come for next class, of course. Integral from 0 to pi by 6 cos power 4 3 theta sin power 6 theta d theta. How to solve this problem? Okay, let's see. Some of our friend has a doubt. Let's see. Fine, I have given 2 homework questions, so let's solve one question which you have a doubt. I is equal to integral 0 to pi by 6, 0 to pi by 6. Okay, then cos power 4 3 theta, and what about the next thing? Sin power 6 theta d theta, sin power 6 theta d theta. This is 3 theta again, sin power 6 3 theta d theta, right? This is sin power 6 3 theta d theta. Correct? Is this what you have? Sin power 6 theta d theta or sin power 6 3 theta d theta again? Please tell me. This is correct, no? It is 3 theta because in the comment you made it, you missed this 3. Okay, fine. So then you can apply reduction formula easily. If this is the gate question, so put 3 theta is equal to t. So this implies 3 d theta is equal to dt, of course. What about the lower limit? T into 0 is equal to 0 is equal to t. So t equal to 0. Upper limit is 3 into pi by 6 is equal to t. So this implies t equal to pi by 2. So therefore, if you replace all this in the given integration, I is equal to integral 0 to pi by 2 cos power 4 theta, sorry, cos power 4 t, cos power 4 t into sin power 6 t. This dt is dt divided by 3. That's it. Okay. So 1 by 6, sorry, 1 by 3 times of integral 0 to pi by 2 cos power 4 t sin power 6 t dt. So if you integrate this, this value becomes 4 plus 6, 10, 8, 6, 4, 2, then it is 4, so 3, 1, that's it. It is started with 6, so 5, 3, 1 into both are even, so k is pi by 2. That's all. Okay. If both are even, k is pi by 2. So pi divided by, so 2 8s are 16, 16 2s are 32, 32 4s are 128, 128 into 4, 128 into 4, 512. Okay, yeah, that's it. Nothing is left. Yeah, pi by 512. That's the answer. Okay. Pi by 512 is the actual answer. Okay. Good. If you have the answer, you can comment whether this is the answer or not. That's it. So thank you all. Then we'll wind up for today. We'll meet again. We'll meet again on Monday. But please solve these couple of homework questions. This is one, and this is also a nice question. Please solve this. Okay. And we'll meet again at 7 p.m. obviously on Monday, and we will try to work out some more concepts of single variable calculus. Okay. So hopefully in the Monday and Tuesday's class, approximately I can finish single variables calculus. Then we'll move to multivariable calculus. So thank you. Thank you all. If you have any queries, you can ask me, or else it's fine. Yeah, thank you all. Take care. Bye. Have a happy weekend, and let's meet back on Monday. But please spend some time on solving those questions. Okay, those two are nice questions which make you think a bit. Thank you. Bye.